Hello friends, welcome to the class. Friends, in this session we are going to discuss concepts of factors. The various points that we'll be covering in the session are number of factors of a number, sum of factors of a number, product of factors, number of odd factors, number of even factors, coprime factors, and sometimes some specific conditions are given. So we'll be taking them also, taking them as well. First of all, we should be clear what exactly a factor is, right? I know that you must be knowing this, but still we go for a quick recap. Suppose I have a number, maybe 10, right? So factors of 10, that means 10 is divisible by how many numbers, right? So it is divisible by 1, 2, 5 and 10. That means there are 4 numbers which are factors of 10. That means 10 is divisible by 4 numbers, that is 1, 2, 5 and 10. So these are the number of factors of 10. Okay. Similarly, number of factors of say number 25. So that is 1, 5, 25. Right. Similarly, we can take some more numbers, maybe 42. So 42, it's 1, 2, 3, not 4, not 5, 6, 7, 14, 21 and 42. Okay, and here suppose I take maybe other numbers, say maybe 121. So that is 1, 11 and 121, right? So 42 has 1, 2, 3, 4, 5, 6, 7, 8 factors. 121 has 3 factors, 25 has 3 factors, 10 has 4 factors, right? So these are the number of factors for these given numbers 10, 25, 42 and 121. Now some one important observation is there, right? That you might have observed. I have taken 4 numbers. Out of these 4 numbers, 10 and 42, these are simple numbers, but 25 and 121, these are numbers as well as perfect squares, right? 25 and 121, both of them are perfect squares, and 10 and 42, they are not perfect squares. So you observe one thing: if the numbers are perfect square, then they have odd number of factors, right? 25, it has 3 factors, 1, 5, 25, that is odd number. And if the number is not a perfect square, then it has even number of factors, right? As 10 and 42, both of them have even number of factors. So that's really important thing to understand. Okay, so various types of questions based on this particular concept, like even number of factors and odd number of factors, are frequently asked in exams. So you should be knowing this. Okay. Now we got one thing clear, that perfect square numbers have odd number of factors, and non-perfect square numbers have even number of factors. Now the next question is, next point is how to find the number of factors. See, for 10 and 42, these are really small numbers. You can find out the number of factors. But suppose if you have very big numbers, you cannot keep on writing each and every factors. You may miss out some, right? So there should be some procedure to get the number of factors for any given number, right? So for that, I suppose I take a very small number, maybe 42. So we will derive the concept for bigger numbers as well. So 42, first of all, what we have to do? We have to do the prime factorization of 42, right? That means we have to factorize 42 among its prime factors, right? So 42 is basically 6 into 7, so it is 2 into 3 into 7, right? So 2 into 3 into 7, that means 2 raised to 1, 3 raised to 1 and 7 raised to 1. So these are over here I have written down the factorization of 42. So 2 3s are 6, 6 7s are 42. Now, how to find out the number of factors? See, we have direct formula also to find out the number of factors, but we need to understand the concept behind this, behind that formula, right? Now, when we write number of factors, right, as I have written over here, 1, 2, 3, 6, 7, 14, 21, 42, they are nothing but the combination derived from 2, 3 and 7 that you can check very well over here, right? One is, that means nothing is there, right? It's nothing is there, I mean the power of this is 0, right? 2 raised to 0 into 3 raised to 0 into 7 raised to 0, so 1 is also a factor, 42 itself is a factor. Okay, apart from that, 2, 3, 6, 7, 14 and 21, they are the numbers which are derived from the various combination of 2, 3 and 7. Now here we will be using the simple concept of permutation and combination. Okay, PNC, just write it in short. Now, see, 2 is having the power as 1, right? So, in how many ways I can choose 2? Okay, in how many ways I can choose 2? I have two choices. I can take 1 2, or I cannot, or I can take no 2, right? That means 0 2s. So, for selection of 2, I have two choices, right? I will take 1 2, or I will not take any 2. So for selection of 2, I have two choices. Okay. For selection of 3, further I have two choices. Either I take 1 3 or I take no 3. Okay. So further I have two choices, and similarly for 7. Right. So 2 2s are 4, 2s are 8. So I select 2 or I don't select 2, I select 3 or I don't select 3, I select 7 or I don't select 7. In all, we are getting 8 ways, right? So these are 8 factors of 42 that you can check over here. Okay, suppose I have any bigger number. Maybe I have suppose 2 square into 3 raised to 3 into 5 raised to 4. Now in how many ways I can choose 2? I have 3 ways, right? I can choose 2. I can take 2 raised to power 1. I can take 2 raised to power 2. I can take 2 raised to power 0. So for choosing 2, I have 3 choices. Okay, 3 ways. What I mean is, so 2 can be chosen in 3 ways, because we have the power as 2, so I can take the power as 0, I can take the power as 1, I can take the power as 2. So there are 3 ways. Similarly, for 3, I can take the power as 0, then 1 or 2 or 3. So I have 4 ways. For 5, I can take the power 0, 1, 2, 3 or 4. So I have 5 ways. Right? So 5 into 4, 20, 20 into 3, 60. So this number, whatever is this, we can get this number by multiplying all these numbers. So this number will have 60 factors. We cannot write all 60 factors, of course, but this number will have 60 factors. Okay, so this 60 factors just you need to understand one very simple thing. When I'm asking you, we can take the power of 2 as either 0 or 1 or 2, the power of 3 as 0 or 1 or 2 or 3, and power of 5 as 0, 1, 2, 3, 4. So in all the cases, we are including 1 0 also, right? So we'll have one case where 2 raised to 0, 3 raised to 0 and 5 raised to 0 will have one combination, and will have one combination as 2 square into 3 cube into 5 4, right? Because we can have the power of 2 as 2 also, power of 3 as 3 also, and power of 5 as 4 also. So when we have 2 raised to 0 into 3 raised to 0 into 5 raised to 0, that means this number is nothing but 1, and this number is nothing but the number itself, right? That means if we are counting the number the factors as 60, it includes two numbers, that is number 1 and number itself. So that should be clear to you. Okay, so in all, if we are talking about the number of factors, that there are 60 of course, but if we are asked about the proper factors, or maybe the number of factors excluding 1 and the number itself, then they will be 58 only. Okay, so you should be clear with this, because while making the combination, we are taking the power of 2 raised to 0, 3 raised to 0 and 5 raised to 0 into consideration, and 2 raised to 2 into 3 cube into 5 raised to 4 into consideration. So we will be getting a 1 and the number itself as factors. Okay, so I hope this concept is clear to you. You can take some more examples. I take a perfect square number, maybe 36. So 36 is 4 into 9, so 2 square into 3 square. So 2 can be chosen in 3 ways and 3 can be chosen in 3 ways. So 3 into 3, number 36 will have 9 factors, inclusive of 1 and 36. Right? You can jot down the factors, not a problem, because it is small numbers. You can write them down. No, though there is no need, but still if you want to verify, you can do that, right? So number 36, we can find out the number of factors. See, this concept you need to understand. How do we find out the number of factors? Because sometimes various conditions are given. Right? How many factors will be there which are multiple of 4, which are multiple of 9, or which are multiple of maybe 6, or some conditions, some other conditions as well. So if you don't know the proper procedure of finding out the number of factors, you cannot do that specific condition based questions. Okay, so you should be clear with this. Now second point is, as I talked to you regarding condition based factors. So if I talk to you about maybe number 36 only, how many even factors does number 36 have? Okay, so we have to find out even number, number of even factors. Okay, now when we were finding out the factors of 36, I just write down the factors for better clarity over here. 1, 2, 3, 4, 6, then 9, 12, 18 and 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if we have to find out the factors which are even, that means we have to find out the number of even factors of 36. So in that case, what we have to do? See, when we are writing down these factors, what we are doing, we are taking the ways of taking 2 as 3, right? That is 0, 2 can have the power as 0, 2 can have the power as 1, 2 can have the power as 2. But when we have to calculate even number of factors, we have to exclude the numbers when 2 is having the power 0. Okay, so the favorable powers either 2 can have is 1 or 2. So in how many ways 2 can be selected? That is 2 only. Over here we have taken 3 because 2 raised to 0 is allowed. But since we have to find out even number of factors, 2 raised to 0 will not be allowed because that number will not be even. Okay, so for selecting 2, we have 2 choices. For selecting 3, of course, we have the same, that is 3 choices, because 3 can have the power as 0. Okay, so in all 2 into 3, that means 6 factors are there which are even. So it's 2, 4, 6, 12, 18, 36. 1, 2, 3, 4, 5, 6. Okay. Now the next question is, maybe they can ask, maybe you can be asked odd number of factors, right? Even number of factors I have calculated. You can deduct definitely from 9, so remaining will be odd factors. But from the procedure, if we have to find out, then what we have to do is we need to exclude 2, right? So we were choosing 2 raised to 0 or 1 or 2, but in this case we just have to exclude 2 because we don't want even factors, right? So 3 can be chosen in 3 ways, right? 3 is having power 2, so 3 can be chosen in 3 ways, that is 0, 1 and 2. So in all there will be 3 odd factors. Okay? So this is how we can do the condition based question. I'll be taking some more typical question because this concept is really important. So we understood one thing, the number of factors. If the number is perfect square, it will have the odd number of factors, as we can see over here. We can find out even numbered, the factors which are even in nature. We can find out the factors which are odd in nature. Now suppose one specific condition is there, maybe how many factors are there which are a multiple of 4. So multiple of 4, if we have to look at, then we have to exclude even the power. 2 raised to 0 we have to exclude, 2 raised to 1 we have to exclude. Okay, so the bare minimum power of 2 that we have to take is the 2 square. So we have just one choice. Okay, because 2 is having power 2 only, so we just have one choice of taking 2, that is just one choice. 3 can be taken in 3 ways, of course. Okay, 0, power 2, power 1 and power 2. So there are 3 ways of selecting 3's, that is power 3 raised to 0, 3 raised to 1 or 3 raised to 2. So in all we have 3 numbers, 3 factors which are multiple of 4. Okay, that can be verified from here. Now suppose you are asked how many factors are there which are multiple of 6. Now multiple of 6, that means we need at least 1 2 and at least 1 3. Okay, so 2 can be chosen in, since we want 2 raised to 1 bare minimum, so 2 raised to 1 and 2 raised to 2. So there are 2 ways only. For 3 also bare minimum we have to have 3 raised to 1. So there are 2 ways, 3 raised to 1 and 3 raised to 2. So in all there are 4 factors which are multiple of 6. Can see 6, 12, 18 and 36. Okay, so similarly you can find out the number of factors if we are some other conditions. I can take some more, can take some big number as well. Now suppose I take a bigger number, maybe 1080. Right, 1080. The first thing is that you need to break it into its prime factors. So basically it is 108 is 36 into 3. So for 10 we can take 5 into 2. So it is 2, that is 4 into 9. So 2 cube, 2 raised to 1 and 2 raised to 2 into 3 raised to 3 into 5. So that is a factorization of 1080. So total number of factors will be 4 into 4 into 2, that is 16 into 2, 32. That is inclusive of number 1 and 1080, right? If we have to exclude them, then there will be 30 factors. Okay, now first question is odd factors. That means we have to find out number of odd factors. So we have, if we have to find out the number of odd factors, in that case we don't have to choose any power of 2, right? Now 3 can be chosen in 4 ways and 5 can be chosen in 2 ways, right? 5 raised to 1, so 5 raised to 0 and 5 raised to 1, 2 ways are there, and 3 raised to 0, 3 raised to 1, 3 raised to 2 and 3 raised to 3, there are 4 ways. So 4 into 2, 8. So there are number of odd factors will be 8. Okay. Similarly, even factors, though you can subtract 8 from 32, still 2 can be chosen in 3 ways because 2 raised to 0 will not be allowed. So 3 ways and then 4 ways and then 2 ways. Okay, so 3 4s are 12, 12 2s are 24. So 24 factors will be there which are even in nature. Now the third interesting we take, how many factors are there of 1080 which are divisible by 10? Okay, divisible by 10. Now 10 can be obtained by 1 2 and 1 5 combination, right? That means it is necessary for us to take at least 1 2 and 1 5. Now since we just have 1 5 but 3 2s are there, so we need to choose at least 1 2. Okay, so at least 1, 2. So we have three choices, right? 2 raised to 1, 2 raised to 2, 2 raised to 3. So for 2, we have three choices. In all, 4 choices, but 2 raised to 0 we have to exclude because we want at least 1 power of 2, right? So 2 can be chosen in 3 ways. 3 can be chosen in 4 ways because if we want multiple of 10, then 3 is not necessary over there. So 3 can be chosen in 4 ways. 5, we have 5 power 1. So 5 can be chosen in just one way because to obtain 10, we need 1, 5 and 2 combination. So we cannot have 5 raised to 0. So we have just one choice, that 5 raised to 1 we need to take. Okay. So 4 into 3, 12 factors are there of 1080 which are multiple of 10 or which are divisible by 10. Okay, so this is how you can find out the number of factors, odd factors, even factors, conditional, whatever is given to you. Maybe you are asked the number of factors which are multiple of 15. Okay, so suppose or divisible by 15, say, right? So for 15 what we need is 1, 5 and 1, 3 combination. So in that case it is not necessary for us to have any power of 2, right? Because we want 5 and 3, 1, 5 and 1, 3 to make 1, 15. Okay, so 2 can we can have further 4 choice, 0, 1, 2, 3. For 3 we have power 3, but we need at least 1, 3. So we are having three choices. We cannot have 3 raised to 0. So it is 3 choice, and we have single power of 5 and we need that. So there is just one choice, just take it. So in all 12 factors are there which are multiple of 15 or which are divisible by 15. Okay. So whatever is the condition, you can find out the number of factors, right? If you are conceptually clear. Suppose maybe multiple of maybe 9 you have to see. So in that case the minimum power of 3 that you have to take into consideration is 2, right? So you have two choices, either you take 3 raised to 2 or 3 raised to 3. So for 3 you have for 2 you have 4 choices, of course, 0, 1, 2, 3. For 3 you just have 2 choices, you can take 3 raised to 2 or 3 raised to 3. For 5 you have further 2 choices, you can take 5 raised to 0 or 5 raised to 1. Right? So 4 2s are 8, 8 2s are 16. So there will be 16 factors which are multiple of 9. Similarly, suppose you have to find out the number of factors which are multiple of 4. So in that case the bare minimum power of 2 that you have to take into consideration is 2 raised to 2, right? So you can take 2 raised to 2 or 2 raised to 3. So you just have 2 choices for that. For 3 further you have 4 choices, because to be a multiple of 4 it is not necessary to have 3. So for 3 you have 3 raised to 0, 3 raised to 1, 2 and 3. Similarly for 5 you have 2 choices, right? So 4 2s are 8 2s are 16 numbers are there which are multiple of 4. 16 numbers are there which are multiple of 9. If you want the numbers to be multiple of 6, then you have to take 1 2 minimum and 1 3 minimum. Then you have to proceed. Maybe for choosing 3 you have 3 ways, because you need bare minimum 1 2. Similarly 1 3, not necessary to have 5. So we have 2 choices for 5. So 3 3s are 9, 2s are 18. 18 numbers are there which are factor of 1080 and which are multiple of 6. Okay, so this is how you can apply various conditions. It's really very easy if you know how to choose the number of ways. Okay, using these powers we are finding out the number of ways. Okay, whatever the damn conditions you have been given, suppose if any number is having the power it's 2 cube into 3 raised to 4 into 5 raised to 4. Suppose you have to find out the number which are multiple of or which are divisible by 1000. Then for 1000 you need 3 2 and 3 5 3 2 and 5 combination, right? So in all the total number of factors of this number will be 4 into 5 into 5, right? 100 factors. Now the number which is the factors which are multiple of 1000, right? So for 1000 we need 2 cube into 5 cube. So 2 can be chosen in just one way, because we need 2 cube, bare minimum is 2 cube. So just we have to take the entire number. So 1 For 3 we have 5 choices, 0, 1, 2, 3, 4. For 5 we have 2 choices. We can take 5 cube or we can take 5 raised to 4. Okay, so we have 2 choices. So 5 twos are 10. That means in all 10 factors of this number are there which are divisible by 1000. Right? So you can take any other combination. Okay. So I hope this concept is clear to you. In the next part, next session, we'll be learning more about factors, because in starting of the session I have told you so many points. So one by one we'll be taking each of them. So I hope this is enough for this session. So I'll see you in the next session once again. Do revise this, do experiment with the factors. Bye bye.